Study Guide 21, problem number 1. So problem number 1 in Study Guide 21, we have to simplify this expression and see which of these four expressions is equivalent to it. So the first thing you want to do is you want to go inside the parentheses and simplify this. This is not the only way to do it, it's just the simplest. So I take these two, I copy the base, and I add the two exponents. There's a 1 there. So 1 plus negative 2 equals negative 1. So I copied the base and I added the exponents. Now, when I have power next to power, that's when I multiply. Negative 1 times negative 2 is positive 2. So this expression simplifies to x squared. So we need to find all the other expressions on there that are the same as x squared. So the first expression is x cubed times x to the negative first. So we simplify that the same way we did right here. I copy the base and I add the two exponents. 3 plus negative 1 is 2. So that's the same. So when I pick my answer, that's going to be one of them. Expression 2, this is expression 1. Expression 2, we have x cubed divided by or over x to the fifth. Now this is where I copy the base and subtract the exponents. I go top minus bottom exponent. If I do the rule for subtraction, I see that I have a negative second power. That's not the same. So I do not pick expression 2. Expression 3. Expression 3 has x squared times x squared over x to the second power. So just like I did here, I do that addition part first. I do x to the 2 plus 2 is 4. And now I do this problem, where I copy the base and subtract top exponent minus bottom exponent. So expression 3 is equivalent to our original problem, and we need to test expression 4 now. Expression 4 is just 1 over x squared. Well, when we flip, that's what we do when we have a negative exponent. We flip it, right? So that's not the same. So the only ones that were the same were expressions 1 and expression 3. Next problem on our study guide, number 2. We have to say how many times larger than 8 times 10 to the 4th. How many times larger than this is this? So that's a division problem. I want to put the bigger number on top. And the bigger number is not the coefficient. It's not the number in front. The bigger number is the one with the biggest exponent. So that's why this one goes on top, because it's how many times larger. So what I do is I go 4 divided by 8. A lot of you would say 2, which is wrong. That's 8 divided by 4. 4 divided by 8 is 0.5. And you can go in and out and figure that out. Now, the shortcut for this, just like we did up here, copy the base, subtract the exponents. But this is not in scientific notation. We have to convert this part to scientific notation. So this is the same as 5 times 10 to the negative first, because I moved that decimal one time to put it in the right spot. This is a small number, so it's negative exponents. And now I have to combine my tens to put it in scientific notation. And this is when we're multiplying like we did up here. Copy the base and add the exponents. Negative 1 and 4 is 3. So it's 5 times 10 to the third times larger. Next one, number 3. We have to solve for k. We're going to isolate the variable to figure out what that value is to make this true. So when we solve for k, we want to simplify first. I have 4 negatives, 9 more negatives. That's a total of 13 negatives. I have 7 k's. Take away 1 k leaves 6 k's. Now I can solve this equation. I work farthest away from the variable first, do inverse operation. These are on opposite teams, so opposite teams means I'm going to subtract. I can borrow if I need to. I get a difference of 138. Except there are more negatives than positives. So that's why it's a negative sign. There's more negatives than positives. This is gone. Isolate the variable by doing the inverse operation. Divide by 6. Positive divided by negative is a negative. So to figure this out, I have to go over here and go in and out. Top goes in, bottom goes out. 6 goes into 13 two times. And I did get a difference of negative 22. We always check our answers in the back when we're finished. Let's see if we're right. And if we're wrong, which I am, what did I do wrong? I didn't drop down my 8, right? I've accidentally put a 12. So that should be a 3. Okay, so make sure you check your answers before you move on. Catch your mistake, like I did. So negative 23 is the right answer there. Okay? Alright, next problem. Number 4 from our study guide. We have to solve this equation. Again, we're going to simplify both sides and then isolate the variable. So we're going to figure out what number goes here to make this all true. So we simplify both sides by first distributing, then combining like terms. Distributing, then combining like terms. Let's separate our left from our right side here. So now, if I'm multiplying 1/2, I just take half of 6. Half of 6 is 3. Times x is 3x. Half of 10 is 5. Now I combine like terms. First I distribute, then I combine like terms. I add my constants with my constants. Like my numbers with no letters with my numbers with no letters. Now I can isolate or figure out what x is by working farthest away from the variable. And this is when we start doing inverse operations. I don't do that before. These are gone. If I subtract these two, now I divide both sides by 3. Not by 51 because the 3 is next to the x. Go in and out. $17 should make this true. Number 5 from our study guide. So, number 5, we have to pick all of these equations that have one solution. An equation will have one solution if you simplify both sides and you see that your x's have different coefficients. It will have infinitely many solutions if you simplify both sides and you see it's the same thing on both sides. It will have no solution if you simplify both sides and you see that you have the same x's but different constants. So, for number 5, equation 1, not expression. Equation 1 is negative x plus 10 equals the opposite of 8x minus 10. So I'm going to simplify this. Simplify just like we did before, just means distribute and combine like terms. So let's simplify. Let's distribute this minus sign, which is like multiplying by negative 1. Change the sign for everything in the parentheses, and the parentheses go away. Now, these are different. I can solve this. If these are different, there's automatically going to be one answer. So expression 1 is part of our answer. We're picking all of the, equation 1. All of the equations that have one solution, that's what we're figuring out here. So that has one solution. Here's the next equation. We're figuring out how many solutions does this have. We don't need to solve the whole thing. We just need to simplify and then we can make a decision. That says 2x, by the way. Okay, so make sure I copied it correctly. So I distribute. 2 times 2x is 4x. 2 times 4 is 8. After I distribute, those parentheses go away. And then I still have the minus 5. I have the equal sign. 6x, I have to distribute that minus sign again. So the opposite of 3 is positive 3. The opposite of negative 3 is positive 3. The opposite of positive 2x is negative 2x. So we distribute. Now we combine like terms. Combine like terms. 4x, 8 take away 5 is 3. Over here, 6x, take away 2x is 4x. Now, we simplified both sides. We have the same coefficient for x. That's a special case. That's either no solution or infinitely many. If these are the same, that means this is the exact same thing. That's infinitely many solutions. That's not what we're looking for this problem this time. Equation. I keep writing EX, sorry about that. Yeah, equation 3. We have negative 5 plus 2x minus 1 equals negative 5x plus 3 times x minus 2. We're going to simplify this. On this side, all I have to do is combine like terms. Negative 5 and negative 1 is negative 6. Over here, we have to distribute and then combine like terms. I didn't do that here because I couldn't distribute. There's no parentheses. So I'm going to distribute 3 times x, which is 3x, and 3 times negative 2, which is negative 6. So that's simplified. This side, I got to combine like terms. That's simplified. I have a positive 2x and a negative 2x. Those are not the same thing. This has one solution. Remember, if they're not the same x's after you simplify it, there is going to be an answer. There's going to be one answer. It's not a special case. So equation number 4 now, the last one we have to test. I have 2 minus 4 times x minus 1 equals x minus 2x plus 18 minus 3x. Simplify both sides. First distribute. We're distributing a negative 4 now because of the minus sign. I got negative 4x. Negative times negative is positive. This times this is positive 4. Over here, there's nothing to distribute, but there are like terms to combine. I have 1x, 2 negative x's, 3 more negative x's. I have a total of 5 negatives and 1 positive. Opposite teams mean subtract. So if I take away 1 is 4, but there are more negatives, so that's negative 4x plus 18. Over here, I got negative 4x plus 6. Now, this is a special case. I have the same coefficient for x after I simplified both sides. So that's either no solution or infinitely many. These constants are different. That means there is no answer to this. This is no solution. So I don't pick equation 4. So my answer for this one was equation 1 and equation 3. Okay, number 6. Number 6 asks us which ordered pairs are solutions. So we have y equals negative 3x. Ordered pair 1 was negative 4, 2. Ordered pair 2 was 0, 0, 3, 4, negative 12, and 4, 3, 9. If I want to know which of these are solutions, then I just plug them in and see if it makes it true. A solution makes it true. It's on the line. So if I plug this in here, x goes where x goes, y goes where y goes. For the first one, I have, this is y, I have 2 equals negative 3 times x. X is this. That's not true. Don't pick 1. Next one, if I plug in 0 to my equation, if I put 0 for y and 0 for x, that is true. 0 equals 0, so that's one of them. I'm going to pick that. Next one. This is y. I put it where the y goes in the equation. Remember, y equals negative 3 times this. That's true. Negative 12 equals negative 12, so I'm going to use that one as well. And the last one. Y equals negative 3 times x, and that's not true. They're not the same size, so don't pick that one. So my answer for this one was 2 and 3. Number 7. Number 7 gives us a graph. We have to find the slope for that. So if I took 2 points, I'm going to take points that are right there on the lattices, right where the lines intersect. And I can see, first of all, this is a negative slope. And so I go down 1 and to the right 3. Down 1 and to the right 3 is a slope of negative 1/3. So I have to look at all of these relations and see which ones has a greater rate of change. That means an absolute value greater than negative 1/3. So if I take my first relation, that table, I can take any 2 points for relation 1. I can take any 2 points and find the slope and see if that is a greater rate of change. Okay? And that's going to be y minus y over x minus x to get 1/4. Okay? Or you can take a shortcut. You see that it is proportional because 0, 0. So you can just put any y over x, 1/4, 1/4. 1/4 is not a bigger absolute value than negative 1/3. 1/4, if I go in and out, and I get my decimal, that's going to be 25/100ths, right? 0.25. However, 1/3, if I go in and out and I divide, I'm going to get 0.3 repeating. 0.3 repeating is more than 0.25. So that's not a greater rate of change. Relation 1 does not have a greater rate of change. Relation 2, same thing. Find your slope. For relation 2, I find the slope. Relation 2 gives us a table. So I'll pick any 2 points from the table. Doesn't matter which 2, I'll get the same thing because it's called a constant rate of change. It's always the same. So I'll go y minus y minus y over x minus x. Now, 4/5 is a fraction that is greater than 1/3. So, number 2 has a greater rate of change. Number 3. Relation number 3 is an equation. That's in slope-intercept form. So the slope is right in front of us. 2/3 has a bigger absolute value than negative 1/3. Number 3 has a greater rate of change. Number 4. Number 4, this is a line containing these 2 points. We're doing the same thing again. We're taking the 2 points and we're subtracting y minus y over x minus x. So I go y, take away y, over x, take away, here's the tricky part, take away a negative. So this is 6 negatives, this is 6 positives. That's a slope of negative 1. Negative 1 has a greater absolute value than a fraction. So, the answer for this, relations 2, 3, and 4 all had a greater rate of change than the graph. All right, number 8. So we had to select a system that correctly describes a solution to this system. Select a statement. So in other words, for number 8, we were given a system of equations. And we had to say whether it had infinitely many, no solution, or if one of these were where these 2 lines intersect, or the solution. So we can just solve the system. We already have a variable isolated, so we can use the substitution method. Plug it in. So I can write this equal to this. Okay, now if I look at that just like we did earlier, if I see these are the same coefficient and this is already simplified, this is either no solution or infinitely many. These are different. This has no solution. I can stop right there. The answer has to be B, no solution. Now, you could also use slope-intercept form. You see that they have the same slope, that means they're parallel, as long as they don't have the same y-intercept. You could have used that as well. Number 9. One equation in a system is this. Which of these other equations, we got 4 more equations, will give you infinitely many solutions? Well, infinitely many solutions means it would be the same exact line. So I'm just going to check to see which of these equations is the same exact line as the one they gave me. And if it's the same line, it'll be the same equation. Meaning I can multiply these all by the same number and get this if it's the same thing. So, if I were to multiply something to get 2x from negative x, I'd have to multiply everything by a negative 2, because negative times negative is positive. If I multiply 8 times negative 2, I get that. If I multiply 5 times negative 2, I get that. This is my answer. This will be infinitely many solutions. The other 3 will not work. Let me show you. I'll take one. 2x minus 16y equals 10. Okay? So, in order to get from here to here, again, I'd have to multiply by a negative 2. Negative times negative is positive. Negative 2 times 8 is negative 16. Yes. Negative 2 times 5 is not negative 10. That means this is not the same line as this. It will not create infinitely many solutions, and the other 2 won't work either. This is one of the only questions where you only have to pick the one that worked. The others you have to pick all that apply. Number 10. Okay, so we had a question. We had one streaming music company that charges $15 per month. $15 per month. Per means it's a rate, means it's each, means it's times. So 15 per month means 15x. The other one is $11 per. 11 per means times, means 11x. $11 per month and a $52 initiation one-time fee means y-intercept. We want to know when they're the same, so put them equal to each other. So, if it's 15 times x, and x is the number of months, we just solve for x. Remember, we got to get our variables on the same side before we try to isolate our variables. And this is how we do this problem. It would be 13 months. Number 11. Okay, number 11, they give us 4 relations, and they ask us which of these are functions. The first relation for number 11 is an equation. And unless you have a y squared or an absolute value of y or something weird like that, and that's all we're going to have to worry about on my test, then it's a function. Now, this may not be a line. X squareds aren't lines, right? We learned that, but we know that this is a function because it's regular y, okay? So that's a function. So relation 1 is a function. Relation 2 gave us some points, some coordinates. And as long as our x's don't repeat, it's a function. So in there we have a -5, 2, and we also have a -5, -2. That's not a function because our x's repeat, so don't pick that one. The x's can't repeat. Relation 3, you see the x's? They repeat. The y's can repeat, but the x's can't. If those x's repeat, it's not a function. Relation 3 is not a function. And the last one, we're going to do the vertical line test. If it only hits it once everywhere, then it is a function. So the answer for this one was relation 4 and relation 1. Those are functions. Number 12. Write an equation for this. Okay, so the long way to do this is to take any 2 points you want. They give us 5 sets of coordinates. You can take any 2 points you want, find the slope, then take a point and find the b. However, they put this in order. You see how it goes in order? If it goes in order, you get to take a shortcut. You can see the rate of change here. It goes down 2, goes down 2, goes down 2. If the rate of change is constant rate of change we learned is called slope. So we already know the slope. And look, they give us a y-intercept, thank you. If they say x equals 0, that's the y-intercept. -1. So this one's done. Equation is -2x minus 1. Alright, number 13. Write the equation for this line, okay? I can see the line intersects right there at -1, so b is -1. Now let's get our slope. Again, we got to go on the lattices. In other words, right where those little crosshairs intersect, right? So there's a point here, there's a point here. It's going down, so it's a negative slope. It goes down 1 and to the right 3, -1/3 is the slope. The equation is -1/3 x, because slope goes in front of x, minus 1, y-intercept goes by itself. They could change the order on you to try to trick you, but as long as you keep the slope in front of x, it's the same thing. Sorry about that. Alright, getting there. Number 14. Number 14, we've got to write the equation for this line right here. Now, I see that as a steep line. Steep lines mean there's going to be a slope that is a greater rate of change than 1, right? Because as long as these are the same, a slope of -1 is 45 degrees, a slope of +1 is 45 degrees. So this is a negative slope steeper than that. So my slope has to be more than a -1 there. Okay, so it could be -3, -5. And then I see the line intersects in between 0 and -5. Answer has to be A. Okay, so we have a steep slope. That's a steep slope, steep negative slope. That means it's more than -1, steeper than -1. And then we take a look at the y-intercept. It's in between, it's in between 0 and -5. So we can do this problem without showing any work. Okay? Answer of the choices they give me, it's got to be this one. It can't be the other ones. It's not a positive slope. It's not a fraction because it's not shallow. So it has to be A. Alright, number 15. We're going to find that missing side. That's a Pythagorean theorem. Okay? we're missing a leg. So if we're missing a leg, we set it up like this. A squared plus B squared equals C squared. So I got to multiply 30 times 30. I got 9 times 9 with 2 zeros. 18 squared. You can go out to the side and do that. 64. Oops. 64, 6, 14. Is that right? 344? Nope. I did something wrong. Sorry about that. It should be, what did I do wrong here? I know it's got to be 224. I'm not finding my mistake there. Do it again. Sorry. There we go. Sorry about that. Alright, so 324. Subtract 324 from both sides. We got to isolate the variable. I got x squared equals. You subtract these two, you get the difference between those two. And you get 576. And then you got to make sure if that's a perfect square, you got to check. Just start multiplying numbers. I already know that 18 times 18 is that, so it's going to be bigger, right? Okay. So then I just guess and check, and I'm going to see that 24 is a perfect square, so it's 24 units long. And you can know from your answer if it's irrational or not, because you won't see, you'll see irrational options. Okay? All right. 16, almost done. 16, again, Pythagorean theorem problem. This time we have two legs. We're missing. There we go. We have two legs. We're missing a hypotenuse. So I go a squared plus b squared equals c squared. Okay. Notice this time that I put the variable on this side because we're missing the long side. So 3 times 3 is 9. 4.5 times 4.5, 6 times, I'm cheap. Okay, so we got 20 and 25 hundredths. Now I got to add these two because they're on the same side. Well, 20 plus 9 is 29. And then take the square root of both sides. And since that's not a perfect square, that's going to be your answer. It's an irrational number. We're at 29.25. Okay, number 17. 17, they give us two sides of a right triangle. This is one side, this is the other side. And the trick is, those two sides can both be legs, or one side can be a leg, and one side can be the hypotenuse. So to solve this, you have to set up two equations. A squared plus b squared equals c squared, or a squared plus b squared equals c squared this way. Okay, so to finish this, the square root and the square undo each other. Okay, so one option is c squared equals 100, and the square root of that is 10. The other option is to subtract 39 from both sides. And then take the square root of both sides, and you get rad 22. Okay? So those are our two options. Alright, number 18. We had a triangle. Again, this is another Pythagorean theorem. We're missing one leg. So number 18, you have h squared, or a squared if you want, plus b squared equals c squared. You would multiply these. Okay, finish that one. I'll let you guys finish that one because we're running out of time here. And number 19, we're going to use the distance formula for that. Or if you want, you can use Pythagorean theorem since I gave you the drawing. Okay, this is 1 unit. This is 3 units. What's the hypotenuse? So we got 1 squared plus 3 squared equals my answer squared. You guys are going to solve that now. And the last one, same idea. But instead of drawing it out, this time I will just use the distance formula. So I'm going to subtract my x squared plus subtract my y squared to get my answer. Okay, so it'll look like this. I have x minus x squared plus y minus y squared and the square root, and that's how you're going to get the answer for that one.